Division of polynomials. In this video, I will enumerate the rules in dividing two polynomials and perform division in two polynomials. To divide monomials, use the laws of exponents in division. For example, negative 6x to the fourth, y to the sixth, zw divided by 12xy to the eighth power, zu. First is we will divide the numerical coefficients negative 6 and 12. So we have negative 6 over 12, and then dividing terms with the same base, we have x to the fourth power divided by x, y to the sixth power divided by y to the eighth power, z divided by z times w divided by u. So negative 6 divided by 12 is negative 1 over 2. Since for the variable x, the exponent of our numerator is greater than the exponent of the denominator, we have x raised to the power of 4 minus 1. For our second variable, which is y, observe that the exponent of the denominator is greater than the exponent of the numerator. So we'll have y in the denominator, y raised to the power of 8 minus 6, and then z raised to the power of 1 minus 1, w over u. Simplifying the equation, we have x cubed, z to the power of 1 minus 1 is z raised to 0, and z raised to 0 is 1. Simplifying the equation, we have negative x cubed w over 2y squared u. Rule number 2. To divide polynomial by a monomial, we use a plus b all over c equals a over c plus b over c. For example, 12x squared y cubed minus 21x to the fifth power y squared plus 3x squared y all over negative 3x squared y. Applying the rule, we have 12x squared y cubed divided by negative 3x squared y minus 21x to the fifth power y squared divided by negative 3x squared y plus 3x squared y divided by negative 3x squared y. Applying the laws of exponents, we have 12 divided by negative 3 is negative 4. X squared divided by x squared, that's 1. Y cubed divided by y is y. Negative 21 divided by negative 3 is positive 7. X to the fifth power divided by x squared is x cubed. Y squared divided by y is y. 3 divided by negative 3 is negative 1. X squared divided by x squared is 1. Y divided by y is 1. So the final answer is negative 4y squared plus 7x cubed y minus 1. Rule number 3. The last rule is to divide a polynomial by another polynomial with at least two terms. This type of division is applied only when the degree of the polynomial in the numerator is greater than or equal to the degree of the polynomial in the denominator. The result of division is expressed as follows. For exact division, which is the remainder is 0, we have dividend divided by the divisor equals quotient. For remainder not equal to 0, we have dividend divided by divisor equals quotient plus remainder over the divisor. For example, x squared plus x minus 3 divided by x minus 1. X squared plus 2x minus 3 can be factored into x plus 3, quantity x minus 1, all over x minus 1. Notice that we can cancel out x minus 1. So we have x plus 3. Another example. X squared plus 2x minus 3 divided by x minus 2. X squared plus 2x minus 3 is also equal to x plus 4, quantity x minus 2 plus 5 divided by x minus 2. we have x plus 4 times x minus 2 divided by x minus 2 plus 5 over x minus 2. Notice that in the first term, we have x minus 2 divided by x minus 2, that's equal to 1. So we can crush it out. So our answer is x plus 4 plus 5 over x minus 2. Divide 5x cubed minus 2x squared minus 18x minus 10 by x plus 2. Another way of dividing polynomials is by using the long method. So the long method of division is 5x cubed minus 2x squared minus 18x minus 10 divided by x plus 2. What we're going to do first is arrange the terms of both the dividend and the divisor in descending powers of the variable. Since the given terms are already arranged in descending power, we will proceed directly in dividing the two terms. The next step is we divide the first term in the dividend by the first term of the divisor. So that's 5x cubed divided by x, giving the first term of the quotient, which is 5x squared. Next is we multiply each term of the divisor by the first term of the quotient. So 5x squared times x, that's 5x cubed. 5x squared times 2, that's 10x squared. So we have 5x cubed plus 10x squared. Then proceed to subtraction. 5x cubed minus 5x squared, that's 0. Negative 2x squared minus 10x squared is negative 12x squared. Bring down negative 18x. Continue the process until the remainder is reached, whose degree should be less than the degree of the divisor. Continuing the process, we have negative 12x squared divided by the first term of our divisor, which is x. We have negative 12x. Then multiplying negative 12x to the divisor, we have negative 12x times x is negative 12x squared. Negative 12x times 2 is negative 24x. Then we'll proceed to subtraction. Negative 12x squared minus negative 12x squared, that's 0. Negative 18x minus negative 24x is 6x. Then bring down negative 10. Then continue the process. 6x divided by x is 6. Then multiplying 6 to the divisor, we have 6 times x is 6x. 6 times 2 is 12. Then proceed to subtraction. 6x minus 6x is 0. Negative 10 minus 12 is negative 22. So our remainder is 22. Therefore, the quotient is 5x squared minus 12x plus 6 minus 22 over x plus 2. Synthetic division. In this part, we will perform synthetic division on two polynomials, differentiate the usual division from synthetic division, and compute the remainder upon performing division between two polynomials using synthetic division. Another method of division, which has a very short and simple procedure, is called synthetic division. Unlike the usual division, which includes the four fundamental operations. The division requires only addition and multiplication applied to the coefficients. This method is applied when the divisor is of the form x plus minus a. For example, divide the following using synthetic division. 3x cubed minus x squared minus 8x plus 5 by x plus 2. First is we'll arrange the terms of the dividend in descending powers of the variable. Since our dividend is already arranged in descending power, so we'll remain it that way. Then second is write the numerical coefficients of each term of the dividend in a row, indicating the coefficient of powers. Replace the missing power with a zero coefficient. So for x cubed, we have 3. The coefficient of negative x squared is negative 1. For x is negative 8. Then for our constant, equal to 5. Next is replace the divisor x minus r by r, And for divisor x plus r, replace it by negative r. Our divisor is x plus 2, so we will replace it with negative 2. Or we can solve it this way. X plus 2 equals 0. Adding both sides by negative 2, applying the addition property of equality, we have x plus 2 plus negative 2 equals 0 plus negative 2. X equals negative 2. Therefore, our divisor will be negative 2. The next step is multiply the coefficient of the largest power of x, written on this part, by the constant divisor. So we'll bring down first 3. 3 times negative 2 is negative 6. So we're going to place the product beneath the coefficient of the second largest power. So the second largest power is degree of 2. So the coefficient is negative 1. So we'll write negative 6 here. And then we'll add it to the coefficient. So negative 1 plus negative 6 is negative 7. Then we'll multiply the sum by the constant divisor and we'll place it beneath the coefficient of the next largest power. So negative 7 times negative 2 is positive 14. So we're going to place it below negative 8. So negative 8 plus 14, continuing the procedure, we have 6. And then 6 times negative 2 is negative 12. We'll place it beneath 5, which is the constant. So 5 plus negative 12 is negative 7. Negative 7 will be our remainder. Thus, the quotient is 3x squared minus 7x plus 6 minus 7 over x plus 2. So the last number on the third row is called the remainder. And the rest of the numbers, starting from left to right, are the coefficients of the terms in the quotient, which is 1 degree less than that of the dividend. That is why our quotient started with degree of 2.